Thanks for stopping by to check out this episode of Vintage Audio Review. In this episode, I'm going to talk about this Yamaha M-80 Power Amplifier. This was sold in 1984 to 1985 for approximately $950, or in today's dollars about $2,700. So it was fairly pricey. It's rated at 250 watts per channel into 8 ohms at 0.003% THD. Now, it was brought to me from a friend, you know him as Ian, episode 5, and it blew the fuses. What I did was to remove the covers, the top and the bottom covers, and I measured all 16 of the output transistors. Now, each of these heat sinks here has 8 transistors mounted on it. 4 mounted here, and then 4 mounted on that side, and 4 here, and then there's 4 on the bottom side. You can't really see that well, but there's a total of 16 output transistors. So I measured all of those, just basic ohm meter, and none of them were shorted, and that was a good sign. After that, what I did was replace the 2 blown 10 amp fuses, and I hooked the M-80 up to my Variac, and I slowly started increasing the voltage, and the current immediately started going up. I let it get to an amp, and nothing was really smoking at that point, and I just let it sit there for a few minutes, and then I got my IR gun and just started measuring around the circuit boards. And the only thing that I noticed that was hotter than everything else was one of the bridge rectifier assemblies, which is on this board here. That board has the 4 main filter capacitors as well as a couple bridge rectifier assemblies, and one of them was running close to 90 degrees, maybe 88 degrees F, where everything else was in the 78 degrees. So I figured it was a shorted bridge rectifier or something downstream from that. In order to get at the bridge rectifier and all that, you had to remove this thing right here, which meant taking out all the screws around the back, most of them anyway, to get this out. There's some screws that hold these boards down right here and right here, just to get a little bit more oomph, and then eventually you can wiggle this thing out. But the fun is still not over with, as there are some spade lugs on these capacitors that stick through, a lot of solder around them, and you have to have the capacitors out in order to measure the circuit board underneath it. Kind of a dumb idea, but that's what they did. And once I got the capacitor out, I was able to determine that indeed I did not have a bad bridge rectifier assembly, but I had a shorted 47,000 microfarad 45 volt capacitor, which you cannot find this exact one anymore. And after a lot of digging, I found that I could get a 47,000 microfarad 50 volt cap with the different terminals. You can kind of see the difference in size. So I was able to grind off the old spade lugs on this thing, and I will solder them onto here and make this thing to where it should be able to push in there like the old one. I'll show a picture when it's done. We'll see what happens. Now, I did not replace the other capacitor. I tested it. Its value was good. Its ESR was good. There's absolutely nothing wrong with it. And to be honest, this is the first shorted big filter capacitor I've ever ran in everything that I've done. I've seen them open and leaky, but I have never seen one as a dead short. The little caps around the circuit board, some of those filter caps, yeah, I've seen those bad, but never a big one. So we'll see what happens. There might be some other stuff going on with the amp, and if it looks good, maybe we'll go ahead and replace the other capacitors. The other 2, which are these 2, are 33,000 microfarad 45 volt caps, and they're equally as hard to get. And I will show you a close-up of this board in a moment. So this is the bridge filter rectifier assembly board, I'm going to call it. And you have a bridge rectifier assembly here. You have one here. There's a couple big rectifier diodes here. There's 4 of them here. And then you have another bridge rectifier assembly with the heatsink around it here, and another one with a heatsink around it here. Those 2 are for the 47,000 microfarad 45 volt capacitors. When I was measuring them with the gun, the one down here was the one that got hot, and it turns out that is the same side as the capacitor that was shorted, where it went. You can kind of tell right here and right here, those are the tabs sticking through, and there's a lot of solder around them. You have to remove those tabs out to get the capacitors out. There's also a little screw here on each side that you need to remove so you can get the capacitors to slide out. I'm not sure how well this is going to turn out, but here is the problem. So you can see the capacitor mount right above the circuit board. So if you want to do any measurements, you got to have a capacitor out. Now, it's the dumbest thing that I've seen in a long time with electronics. So Yamaha may make good product, but if you got to work on their stuff and it's like this, it sucks. And you can kind of see the terminals right here, these kind of weird terminals. So you can see the terminals on the capacitor there that slide forward. But anyway, that's kind of the nightmare that you got to go through. Heaven forbid you got to start replacing output transistors. So here we have the modified capacitor, and I matched the spacing from here to here to be the same as from here to here. And I think that this is this terminal here is the same point as that one, and that terminal is the same as that, but I did connect them with some solder wick. Everything is solder. Put some foam here and here so that it'll fit into the holder with some pressure, and we'll see what happens. So here we have the capacitor all mounted. There's foam here and foam here to hold it in place a little bit better, although I doubt it's going to be sliding much. That is how it fits in with the other three. So if you are observant, you will notice that the new capacitor is no longer in there. And I hate to admit it, but when I had pulled out the bad capacitor and measured it and it was a short, I figured the problem went away, and then I just went on, got the new capacitor, put it in and all that. And as I mentioned just a little bit ago, I was going to slowly bring the M80 up using my Variac and watch the current. Well, the current was going up the way it did before. So that was kind of a bummer. So I had to pull the capacitor out, which is not fun because there's a lot of solder around those tabs and it's at an odd angle, and one of the terminals is difficult to get out with the soldering iron. Anyway, once I got the capacitor out, I started measuring things, and I should have actually measured across the terminals to see if there was still a short there, which I did not do until I'd already put the new capacitor in, and there was still a short there. Anyway, long story short, it turns out that the bridge rectifier, which was the one I pointed to that was getting warm, that guy was shorted across two of the pins. Unfortunately, this is a D5 FB20, and they don't make them anymore. I couldn't find any anywhere. So I was able to pull the specs on it, and I happen to have an NT5316. You can see it here. And I cut up some heatsink material and mounted it, and it is ready to go. So you can kind of tell they're pretty close to the same amount of material for heat sinking. It should work just fine. The NT5316 has a little bit higher current rating and voltage rating than this guy, and with the heatsink on there, it should work just fine. So hopefully when I'm back again, the unit is all powered up. So I thought I would show where I was at with the M80, which oddly enough is a firecracker name, as I recall. Anyway, I got it all together, well, except for the covers on the top and the bottom. And let's go ahead and fire it on, and I'll show you what I have found. We do have a protect LED that's on. There it goes off. You hear a relay go off. Thing looks okay. So I'm going to go ahead and apply some power to the unit. So I hooked up my QA402 analyzer, and I got it putting in a kilohertz, and I have good news and bad news. The good news is that no fuses blew, and my right channel seems to be working fairly well. It's set up right now that I've got a little over a watt. However, the left channel is reads about 438 milliwatts. So there are some issues with the left channel. Now, another issue that I noticed is here is the power meter, but the power meter is indicating like 18 watts. So it's off now. It may be off because there's some switches here for your load. So it has 8, 4, and 2 ohm, and it's stuck in a 2 ohm load. So my guess is that the meter thinks it's a 2 ohm load, so it's going to display the power that would be going into a 2 ohm load. But the fact that these won't unstick is a little bit of a concern, so I'll have to take that apart and see what happens. So it's encouraging, but it still needs some more work. Now, there is some corrosion from the epoxy that Yamaha used in their infinite wisdom. Back in the 80s, Yamaha wasn't the only company that used this epoxy. Around capacitors and stuff, and it got over stuff and could cause corrosion, and I do see some of that going on. So I'm hoping that once I get those components pulled and replaced, that it'll work right. So I'm going to zoom in on it and show you exactly what I'm talking about before I get into it, but I kind of wanted to do a progression of the repair of this unit. I also ran just the right channel, and I got it to run up to 250 watts, which is the spec, and it looked really good. I think, in fact, that it was meeting the spec requirements for THD and SNR at that point. So that's kind of where we're at. All right, so here is the area, hopefully it'll show up where I'm putting the LED, where you can see the corrosion from this glue. I'm not sure how well it's going to show up, but some of these resistors have some corrosion in some of the diodes there. So that's kind of what I got to do, is unsolder them and then replace them, and hopefully they will solve my problem. So I was able to remove the epoxy around most of the components, and in particular one component, the capacitor, it was either C111 or C112. They are 220 microfarad 6.3 volt capacitors, one for each channel. When I had removed it, one of the leads stuck inside the circuit board because it had corroded off. So that one, I am pretty certain, was causing the problem with the low gain on the left channel. So I replaced both capacitors, even though the other capacitor was fine, and cleaned up the corrosion damage due to the epoxy and hooked up the amplifier, and it looked really good. I just ran a basic test. I was able to get 265 watts, and it pretty much met its specification requirements at that power level. So I shut it down, and I decided to tackle the problem with the display not working correctly, mainly because it was stuck on the 2 ohm position. And I pulled out the switch that was there. So there's a 2 ohm, 4 ohm, 8 ohm position. They're all identical switches, but they do have a slider that allows the one, when you press one, it releases the other switch. So one is selected at a time, and they're kind of all tied in together. I'm going to zoom in on it to show you where the problem was, but with a little bit of this 401 neutral control cleaner and a little bit of this, this is Liberty oil. I got this from Amazon. It's got an eye drop. It's like sewing machine oil. A little bit of that, and worked the little switch. There's a little spring on it, and kind of worked it back and forth, and now it works fine. So I'm hoping that the contacts inside are okay. But I am going to go ahead and I will go ahead and show a close-up of that as best I can, and solder it back in and see if it works and go from there. I'm hoping that I'm about done with this amplifier. Anyway, that's kind of where I am at with the repair. Now, in order to get the faceplate off here, there's just a couple of screws on the top, and then there's maybe 5 or 6 underneath, and you just remove those and then it slides out. You want to be careful because it's glass, actually, in this case. You do not have to remove these side panels. There are some side panels, there's 2 screws on each side panel, and you do not have to remove those to get the thing off. That's where it's at with the M-80 amplifier. So this is the solder side of the switch, and the little mechanism is this little, there's a little spring here and this little slider, and every time you press a button, it engages or disengages that little slider here, and it just needed to be lubed kind of so that it gets underneath here and underneath here and then around here, and just kind of worked it a bit, and it seems to function fine now. So when you press one, it will release the other one. So that's kind of the rework I did on this, and hopefully it's going to work properly. I was finally able to get all the M-80's problem solved and put it back together. Now the load impedance selector switch, this guy right here, last you saw I had lubed it, and when I put it in it worked fine. However, that wasn't the reason that the left channel was not displaying on the power meter correctly. That happened to be the range switch. So I unsoldered that and was able to get enough cleaner lubricant inside it that it caused it to work properly again. And so now the display works rather well. A couple other things I forgot to mention earlier. The weight on this thing, it's like 51 pounds, so it's pretty heavy to move. Okay, I just wanted to cover some of the functions in the operation of the M-80, and I'm going to go ahead and turn it on. The protection light will come on and it'll go off and you'll hear a relay click. There we go. Now you have this auto class A switch, and in theory that puts it in class A mode up to about 30 watts, or if there's any peaks that might hit higher than 30 watts. In my testing, I never could tell a difference when that was on or not. There'll be a piece of data with the unit running, and there's really no difference between having auto class A on or off. Also, we have a peak hold switch, and that will hold the peak of the power meter signal just another second longer or two so that you can see what your peaks are more easily. There is a range switch, and that will multiply the range on the power meter by 0.1, so it gives you some more sensitivity for your lower volume levels. You also have your load switch. You have a 2, 4, and 8 ohm load switch. Those have nothing to do with the condition of your load hooked up to your speaker terminals. It strictly changes the resistance going to the meter circuit for the power meter here. That's all it does. And I did calibrate it for 4 ohms. Now, I calibrated using my audio analyzer, so it's calibrated for 180 watts into 4 ohms. And it's not quite linear, so if I get down to 60 watts, it may be reading 50 watts when the meter goes off. So it's calibrated at one point, at 1 kilohertz, at 4 ohms, with the switch on 4 ohms, but it's not 100% once it gets lower or higher than the 180 watts. You also have your gain controls for each channel. I always keep those at max, so the signal is going straight through those input pots. Now you have 3 different speakers here. You can run A, B, A plus B, A plus C. 2 8 ohm speakers you could run, A and B. You have to look at the manual for the different combinations, but when you start running B and C, it puts them in series, the speakers in series, and it specifies the different impedances that you can run with this. It's really not designed to run in a 2 ohm load, but it does specify a short burst of power into a 2 ohm load, although I did not do any testing. But it's basically for maybe 2 8 ohm speakers, or a 4 ohm speaker and an 8 ohm speaker probably would work just fine with it. The owner's manual goes into quite a bit of detail about the different switch positions and the different loads. So let's go look at the back of the M80 now. So this obviously is the rear of the M80, and we do have a pair of gold-plated RCA input jacks there. We do have a nice grounding lug terminal there. We have the voltage selector switch here. And something unusual, I have not run into this on a power amp, but it does have an unswitched outlet, which was handy when I was doing some testing with it as a complete system. Also, you have the 3 sets of speaker terminals there. Now these are really nice to grab onto. They're big, there's a lot of room. They unscrew here, and you can push in the end of the wire here and then tighten it. You can put the wires down from the tops on the plus terminals and from the bottoms on the red terminals if you want to do it that way. They are not banana jack friendly, but there is a lot of room, and I kind of like all the space they gave you for that. And over here it explains the different speaker combinations and the loads for them. I just wanted to give an idea of what the M80's power meters look like when they're working. It is kind of dark where I'm filming this, so it's not the clearest display, but at least it kind of gives you an idea of how they move, what the display actually looks like. The first piece of data I am showing is the THD SNR plots for the M80 at 1 kilohertz running about 5 watts into an 8 ohm load. Now the spectrum on the left is for the case with the auto A switched off, and on the right the auto A is switched on. There really is not much difference between the 2 spectrums, nor is there really any significant difference between the SNRs or the THDs for the most part. Also, on the plot on the left, I was pointing out where the 60 Hertz hum line was, I will call it. So that would be the one that has a marker 1 above it, and it is 105 dB down. So that tells me that the filter caps are working pretty well. Here we have the frequency response of the M80 with it putting out 5 watts into an 8 ohm load, and it looks really good. The separation is less than 1/10 of a dB between channels, and it's only down about 0.32 dB at 20 kilohertz and down maybe 1/10 of a dB at 20 hertz. So it has outstanding frequency response. And for the 4 ohm load under the same output power conditions, we're down just a little bit more at 20 kilohertz, maybe 1/10 of a dB more at 0.42 dB or so, and also the channels still have great matching and are only down 1/10 of a dB at 20 hertz. Here we have the THD SNR plot at 1 kilohertz into an 8 ohm load with about 265 watts of power being put out. There is a spec on it, and it is less than 0.01%, and we are a little bit above that, so that's not too bad. And the requirement for SNR was better than 96 dB, and we're at around 92 dB, so I'll say that's pretty darn close for an amp that is about 38 years old. Here we have a graph showing the THD versus frequency for a couple different output levels with the M80 going into an 8 ohm load, and it is for both the left and right channels. Basically, the spec on the unit was a maximum of 0.03% THD, and between 40 hertz and 20 kilohertz, we're pretty much at 0.04% THD or better, and from 40 hertz to 20 hertz, it's up to maybe 0.1% THD. So overall, it's looking pretty good. So this plot is pretty much the same as the previous one, except that this is with the M80 looking into 4 ohm loads, and the power levels are a bit different, but it shows similar results as far as the overall THD, being that below about 40 hertz, it's running at not more than 0.04% THD, and from 40 hertz to 20 hertz, it gets as much as about 0.1% THD. And this is a plot of the output impedance of the M80, and the worst case is about 0.25 ohms, and that translates to a damping factor of about 32. And for our last piece of data, we have the multi-tone test for the 8 ohm load. The 4 ohm load looked almost identical, and it's showing about 16 bits of distortion-free range, which is pretty good for most of the amplifiers that I have measured thus far. For my listening test of the Yamaha M80, I connected my Klipsch KG2 loudspeakers that I recently reviewed, and I connected up my Carver C1 preamplifier, as well as my Surfans music player. I've mentioned this every now and then. It's a small little device that you can put a micro SD card in with all your music. I use .wav files. And it does have a headphone jack and a line out jack, and it works really well for what I do, and it's a nice little device. And one day I'm going to review that and compare it to some of the old portable CD players that I was using prior to when I got that. Anyway, with the Klipsch speakers, I had to be a little careful that I did not overdrive them with this amplifier. For the most part, I didn't need to hit over 60 watt peaks according to the power meter here, and everything sounded fine. The amplifier never got more than warm. It's a cool running amp for the most part. I don't know what it would have happened if I ran it in Class A, but I honestly don't see any benefit in running it in Class A, Auto Class A. And I thought the amp works rather well. I like the way the black and red backgrounds go together. Overall, it is a very nice amplifier, and it is capable of probably driving lots of different kinds of speakers. Now, while testing the amplifier into 4 ohm loads, I did run into a little problem while testing this into 4 ohm loads. When I hit in the 350 watts per channel range, I did blow one of the 10 amp fuses, and now I can understand what the reviewers were saying back in the 80s in audio and stereo review when they would blow fuses on amplifiers during their testing. Now, in reality, you're not going to be running probably music that's approaching a 10 amp draw on this. I mean, I'm putting in a pulse sine wave, and that is not going to be what you're listening to, I hope. And so I doubt you're ever going to run into a situation where you actually blow the fuse on this because you are hitting the max power level. But other than that, I thought the amplifier performed rather well, and I would recommend it. If you were to purchase one that's non-working, hopefully you know how to work on them yourselves, because if one of the output stages are broke or both of them are broke and you have 8 to 16 output transistors that you would have to match and all the associated components, it would not be a fun task nor a inexpensive task. So that would be my only caveat with an amplifier like. There was one data plot that I showed the level of the 60 hertz hum. That was over 100 dB down from the 1 kilohertz signal. So it's way down in the mud, and what that tells me is right now I don't have to replace any other caps. That's pretty far down there, and the SNR of this unit is just really good, and it's not because of some large 60 hertz or 180 hertz or 120 hertz hum that's coming through. So my decision to just replace the one capacitor that was shorted seems to be a pretty good one, although there are a lot of people that would say, well, you ought to replace the other three, and there's another two big ones as well. But this unit has great SNR, and I don't see any reason to do that at this point. The owner didn't either. So once again, I thank you for spending some time watching this episode, and I would love to hear any comments that you might have. And if you have not subscribed, please do so. And have a great day or night.